I hope you are fine, doing well in your life. So today we are going to solve the LeetCode problem from the LeetCode 75. Actually, we have solved the first problem from all the topics before try, and today we will see how to implement try. So let's see. The problem is implement try. So today we will see how to implement try. So we will see what try is, what is the importance of try data structure, what is the use of it, how, where we can use it, how it is storing the how it is store the strings, why it is called prefix tree. All these questions we will discuss today. Okay, and then we will see the code of implementation of try. Actually, I have already written that code, but I will explain you in detail. So let's start. So first of all, what try is, right? So let's take an example. I will not take this example, but I will write some write something. Okay, anyways, so first of all, what try is. Okay, so first take the example apple, A-double-P L-E. Sorry for my handwriting. I am writing from the mouse pad. Okay. The second is APP, A-P-P. Those guys, those who already know what try is and their use cases can skip this video. If they want to revise all those things, they can continue watching. Thank you. So second example APP. Third is A. Let's say I am starting from A only. ART. Let's say. Fourth is ALT. AL, right? Anything. So APL. Let's say APL. So first of all, I will insert all those things in the try. Then I will search. Okay. I will also search for the prefixes for AP and APT. A P T. I will search for these prefixes, not those words. I will search for these words. I will show you how we can search for these words. Okay, so let's make a try. So in the first place, what we do, we will make a root node, right? And we will initiate it with the empty map and a boolean which is and is equals to false. I will explain everything, just stay with me. Then we will do insert. In the insert, what we will do, we will insert the character inside this try. And how to insert those? So let's take the example of apple. So in the apple, what the first character is? First character is A. We have root node. We will check if A is present in this root node or not. So as this is empty, so no A is present. So we will insert A in the root node. We will map it with the empty try, a new try, right? Okay, we'll also take an example of bat, just in the case, right? Okay, now we'll go to the next character. So next character is P, and we go to that node. So node is nothing but np dot map ch is A. So we are at, so node will point here. Okay, we are at this node. We have character P. We can check that P is not present. So we will insert P. We will make another try. We will make another try which is an empty node. Then we will again insert P because P is not present. We are P. Then we will go all have the boolean and false, right? So I'm not writing because this is default false. Then P will then again point to that new character L, again new character, new try, empty try, and then we will insert L, which then point to again new try, empty try, and then insert E, which then again point to an empty try. Let's make it here empty try. Okay, so now we have created this empty trie, we have a node at this empty trie. Okay, and we have completed this for loop, so we will not insert anything right inside it, and we will make the end of that for loop for end of that node, because we have currently pointing this node. We can check it here that we have currently pointing that end node, right? So we will then make the end is equals to true, so we its end is equals to it is true. Okay, all these are false right now. Okay, now let's insert app. So what we can do, we are starting with the root node. This is root node. We will start with here. Okay, we have characters, we have a for loop. We can check that a is present, so this if get passed, this will not go inside the if, because it will check if a is not present. We have a inside this, so we can go to that map of map of a is this node. So we are currently at this node, we have a character p, we are currently at this node, and we can check that p is present, so we can go here. So we are currently at this node, we can check p is there, p is present, right? Okay, so p is present, so we can go to that its child node, right? So we are at this node. We can say that so what we can say, it's obvious that our for loop is getting completed. So what we'll do, we'll make the current node ka end true. So current node is this, so we'll make end is equals to true, right? This true signifies that we have a string above this, right? So this is true, means we have a string till here, right? A p p l e, so we have a string here. This true signifies that we have a string a p p, right? Okay, anyways, again insert art. I hope you guys are, you guys can insert it, but let's I suggest you to give it a try. Okay, so let's start art. So we have a, we'll go to the root node. Okay, so we can check that there is no r, so we will insert r, and we will go to the root node of r. So r will point to the empty try, and we'll insert t, because there is no t present in this node, and this will point to the empty try node. And as this for loop getting completed, this point, this node will have a end true. That means we have a string art. 2 मिनट से आता हूँ, आता हूँ सर, 2 मिनट बाद. Okay, so I will not explain this apt. This is obvious that this it is not printing. Okay, sorry. Okay, so now we will insert b bet. So we don't have b here, so we'll insert b, then a, then t. I hope this is enough to make you understand that how to insert any string in a try. Now how search works, right? So let's search for app, right? So this is for insert, right? Let's try for this search. Okay, so how search work? It is first point to the root node. So this is the root node. Okay, this tool is very slow, guys. Okay, anyways, this is for the root node. This will search that if that current first character of the word. So let's say we are searching for the apple. So first character of the word is a. So is a is present in this root node? So yes. So it will then point the node for the child of the a. So then it will check if p is present in this child. in this current node. So yes, p is present, so it will then go to the node of that p, which p points. So then p is again present, then it is l, then l present, and e present, right? So this is how it gets searched, right? It first start with the root node, check if the first character is present or not. Yes, then it will go to the value of that character. The character is nothing but a map, so it will go to the value. Character is nothing but a key having a value. Value is also nothing but a node of a trie, right? So it has a value as a node, so it will go to that node. I will call it a child node of that a, so it will go to the child of a. Then it will search for p. P is present, it will go to the child of p. Then it will again search for a p because two p's are there, so it will go to the child of p because p is present. Then it will search for l. So yes, l is present in this child, so it will go to the child of l. Then it will search for e. So yes, e is present, so it will check, it will go to the child of e, and it will check that if the child has and is equals to true. So if and is true, that means this is a string present in the trie. So it will return true if and is true. Otherwise, if and is not true, the default and is false, so it will return false. So this is how it will search. Let's search for the app. It will same things, right guys? Now we will search for, so I hope you understand this search operation. Now we will go for the start with operation. So start with has nothing, but it will check that if the prefix is present or not. It will not check for the whole string, but it will check for the prefix. We will pass the prefix here. Let's say we will pass ap. So we will start the similar operation as a search, but there is a one difference. So I will explain you. So what we do, we will start with the root node. We can check if a is present. Yeah, a is present, so we will go for the child of a. We can check that if p is present. Yes, p is present, and we will go for, so if p is present, we'll go for the child of p, and we will just return. We will not check if it is ending here or not, if and is true or not, because and equals to true means that the whole strings end here. But we don't have to worry about it. We just check if there is any prefix, there is any string which has a prefix start with ap, right? So prefix means any strings start with, right? So if any strings start with the ap, it will return true. So as you can see, two strings are starting with ap. Actually, three strings are starting with ap, so it will return true. Let's search for the apt. We have a at the root node, then we'll go to child of a. We have p at this node, so we'll go to the child of p. We don't have t, right? We don't have t, so it will return false. We can also see that there is no strings which starts with apt. So this is how a trie works. This is how we can insert a string in a trie. This is how we can search for a string in a trie, and this is how we can search for any prefix in a trie. The trie stores our strings in this way that all the prefixes of the combined, all the prefixes of group of strings has a common prefix, right? Will store in a single character, in a single memory. So it's trie is basically, that's why trie is also called a prefix tree, because it stores the prefix in a single chain, right? And trie is basically used for different type of problems, but most of the time we use trie in XOR problems. If you're gonna solve these XOR problems, right, so you will see the implementation using trie, or you can see the solutions using trie. That because if you will go there, right, you can understand that how it is using, how the guys are using trie for solving XOR problems, right? Or also we can solve the prefix problems using trie. If we have to find the common prefix of, let's say, n strings, so we can use trie. So there are different problems which can be solved using trie. Trie is very strong and very good type of data structure. So I suggest you guys to go through this whole video again to And I will also suggest you to implement this. Trying to draw this whole process again by yourself. And yeah, I hope you understand this implementation of try. Actually, let me explain you the code again, but I have already explained you everything, but still, this is this is the empty node. Then we will insert using this insert operation, then we will search. I have explained you everything in very detail, so that's all for try. Along with these LeetCode 75, I want to share you something that we are also solving the LeetCode daily problems in a different playlist. You can also go there. I will share the link in the description. Go there and have a look on these videos. Along with these, we'll start with a new series in which we can discuss these different algorithms. These algorithms have a very strong these are very strong algorithms which can be used in a competitive programming, right? So these are the algorithms from the competitive programming. We will discuss it in a very detail, and then we will solve the problems from these algorithms, right? So this is how we can we can make our problem solving skills strong, right? Along with this, I've also created a WhatsApp channel or WhatsApp group. I will share the link in the description. So where we can discuss where we can discuss the doubts, where we can discuss the problems. We can solve problem together, or there are many use cases of the group. We can also start with a good project which we can write in the resume. Also for freelancing projects, that group will be useful. So if you want to join that group, you can click on the link which I will share in the description. So okay, that's all from my side. Thank you for your time. Thank you.